and thank you for the invitation. Thank you to anybody who's on the call. The purpose of my talk today is to at least set the stage for and try to explain all the work that we've had to do in our lab at MIT to get ready for this particular pandemic era. This event happened kind of abruptly for labs. I think it was probably a month between, maybe less than a month between the time that everybody was working normally and MIT and a lot of other universities said, okay, shut everything down, send everybody home. And from that moment on, we asked the question, how are we going to restart our research? Because this was a big deal. And so what I'm going to explain today, or what I'm hoping to share today, is the work that we did at MIT in order to put the right process and support and procedures in place so that when the research staff returned, when our graduate students and our postdocs came back in and wanted to start doing chemistry again, that we would be ready to support them in a way that was safe from an infection control perspective, and that was as efficient as we could make it for people to get the data that they need. In the lab that we run is an extremely busy lab. We have a lot of users. We have fairly high throughput. And so it was really on us to make sure that not only could we keep everybody safe, but that we could provide the support that we needed in NMR in particular, but also in mass spectrometry, in EPR, and in a few other areas that we do support. So first slide is actually the same as the last slide. I just want to let you know who the key actors are. The folks that I work with in DCIF, and that's not only the staff. Here, I'm going to change my pointer to a laser pointer. John, Mohan, and Bruce. John and Bruce are NMR spectroscopists. Mohan is our resident mass spectrometrist. But also the group of DCIF stewards who are graduate students who help us to take care of some of the more routine things, to respond to emergencies. They're an outstanding group, and we're lucky to have them. Our faculty sponsor has been a key supporter of all the things that we do. And the chemistry department has given us plenty of go-ahead. I mean, we had lots of discussions about how we were going to manage this. But for the most part, they were confident in our decisions and gave us the support that we needed. So to outline the talk, what I'll do is show you the things that we already had in place in the lab. And a lot of this is stuff that you put together in a lab so that you can run at high efficiency. And then we'll devolve into what we had to do to shut down, how we managed the lab when research wasn't going on, and then what our operational strategies were for the phased ramp up to research that the Institute employed. And so if you look at this in terms of timing, the shutdown happened mid-March. So between probably March 1 and March 15th, everybody was told, close down your labs, make sure that they're safe for the long term. We don't know how long you're going to be out of business. So that was March. By mid-March, everybody was gone except us, you know, emergency personnel. Phase 1 started mid-June, June 15th. And so in that 3 months, we developed ramp-up plans. We supported any COVID research that was going on. And it was really our chance to make sure that anything that we thought was going to work out properly would actually work out properly. And then by mid-July or so, we were in phase 2. And we've been in phase 2 ever since. Okay. And so some of the key points are that in phase 1, we really ran a pretty restricted lab. In phase 2, we opened up almost fully. And so I want to show you how we were able to do that. There is no phase 3. So my guess is that phase 3 will happen when there's widespread vaccination and coronavirus is less of a concern as a worldwide pandemic. So, but for our lab in phase 2, we're basically running at 100% of capacity. So I don't think it'll change much for us. To give you some insight into what the general framework of the lab looks like, we'll divide it into NMR lab on the left, mass spectrometry lab on the right. All of these purple dots are instruments. The first number represents the field strength. The size of the circle represents the 5 Gauss field. So we have all shielded magnets. The oldest shielded magnet, the 502, which is our JL instrument, has an older style shielded magnet, and that's why it has such a big circle. And you can see from these dimensions that it really is a pretty big lab. So I've joked in the past that NMR systems really have never had to worry about social distancing because, of course, with field lines and all that, you would never be within 6 feet, one magnet to another, except for the most modern era where you can have magnets like the 402 all crammed tightly together. But so we really do have a lot of space on the NMR side. On the mass spec side, not so much. And that will be one of the keys. What I'd like to do, John Grimes put together an introduction to the lab that is really a good way to see things. And so what I'm going to do is I'm going to stop sharing my screen. Oops. So apparently if you use a laser pointer, it doesn't work very well. All right, so I'm going to stop sharing my screen. Now I'm going to start sharing my screen, but I'm going to start sharing a QuickTime movie. And so this is about 9 minutes. So for 9 minutes, you'll hear John, you won't hear me.
The Department of Chemistry's instrumentation facility is found in the sub-basement of Building 18. The main entrance is to the right after you exit the elevator doors. To prevent the DCIF from becoming a hotspot for the spread of COVID-19, we have strict requirements. Gloves should never be worn into the lab, even if you just put on a new pair before leaving your lab. Dispose of any gloves in the trash can next to the main entrance. You must enter the lab wearing a mask and keep it on at all times. New users will not have badge access to the facility and will need to ring the doorbell, which is located in the center of the left-hand door panel. Once you have been trained, your badge will be activated, and then you may use the badge reader
Walt, the sounds went away.
and do not use flask, glassware, or small vials to carry your samples around in. The sink is to the left of the door, and there should be soap for washing and paper towels for drying located right next to it. Gloves are on the table next to where you placed your samples. After you have dried your hands, please put on a fresh set of gloves. If any PPE supplies are out, please notify a DCIF staff member and we will replace them. If you empty a box of gloves, please throw the box in the trash. Rules and notices are posted on the monitor in the hall and on signs throughout the lab. Please take time to read and understand them. If you can't, then ask a DCIF staff member for help. To the right of the main entrance is where all of the mass spectrometry instrumentation is located. Towards the left of the main entrance is where the NMR instrumentation is located, as well as the EPR, the polarimeter, and the FTIR. There are two lab exits, both on the NMR side of the lab. The main one is next to the EPR, and there's a second exit next to the 401, which leads to the basement level. Gloves and masks should be worn at all times when you're in the lab. Dispose of your gloves at the main exit as you leave. Use your elbow or hip to open the door to exit, not your hands. Always maintain a distance of 2 meters from others in the lab and limit the time that you spend in the lab. All NMR instruments in the DCIF are named numerically. There are 5 automated instruments and 2 manually operated instruments. New users should first submit a training request for Brooker automation on the main DCIF webpage. This will gain you access to the 402, 400, and 500. All of the automated systems except the JL are operated by Brooker's Icon NMR software and will behave in the same way. These have the same capabilities as the manual instruments and will email you your data. The 402 is a 400 megahertz system with a room temperature broadband probe. The 400 is a 400 megahertz system that is equipped with a Prodigy liquid nitrogen cryoprobe for enhanced sensitivity. This is also a broadband probe, allowing acquisition of NMR data from a range of nuclei. The 500 is a 500 megahertz system, also equipped with a Prodigy liquid nitrogen cryoprobe for enhanced sensitivity. The 502 is a 500 megahertz system. It's produced by JL Instruments and is equipped with a probe capable of being tuned to fluorine and proton at the same time. This allows for acquisition of carbon spectra while simultaneously decoupling proton and fluorine. The 600 is equipped with a liquid helium-cooled cryoprobe. This system is for more advanced users, and only after someone has demonstrated proficiency in the use of the other instruments will they be granted access to the 600. The other instruments in the lab consist of 2 manually operated systems. The 401 is identical to the 400, except that it is manually operated. The 501 contains a room temperature broadband probe that is capable of variable temperature between -100 Celsius and 100 Celsius. This is also the instrument that we use for solid state NMR, as it is equipped with a magic angle spinning probe. Finally, we have a polarimeter for measuring optical rotation and a Brooker Alpha 2 FTIR instrument equipped with a diamond crystal attenuated total reflectance accessory. We then have a Brooker EMX Plus EPR that can be cooled to cryogenic temperature with the aid of a Brooker Cold Edge 4 Kelvin waveguide cryogen-free cryostat. The standard operating temperature range extends from 4.5 Kelvin at the low end all the way to room temperature at the high end. If we go back to the main entrance and over to the mass spectrometry side of the lab, instruments are laid out in bays. The first instruments we encounter are the GCMS and LCMS, which are located right next to the door. The LCMS has an Agilent Infinity 1260 LC attached to an Agilent 6125B MS detector, which utilizes an ESI source. The GCMS has an Agilent 7980B gas chromatograph attached to an Agilent 5977B single quadrupole MS detector with an EI source. Both are equipped with auto samplers. In the next bay is the JL AccuTOF high-resolution mass spectrometer equipped with an IonSense DART source. In the third bay can be found a Brooker AutoFlex LRF Speed MultiTOF mass spectrometer and the Agilent QTOF. The QTOF consists of an Agilent Infinity 1260 LC system attached to a high-resolution Agilent 6545 mass spectrometer, which utilizes an Agilent Jetstream dual ESI source. Lastly, at the end of the lab can be found the Agilent Infinity 1262 HPLC with UV detector. This can utilize both HPLC and UPLC columns. The last resource in the DCIF are the computers in the computer lab. NMR and MS data processing software are available, as well as ACD Labs NMR prediction software. As you can see from this panorama taken just 2.5 years ago, we have transitioned from old and dated equipment to a state-of-the-art facility featuring all new instrumentation. Please remember, this is a shared resource. The instruments need to be taken care of and not abused. Please do not rush. Pay attention to the instructions DCIF staff members give you so that not only will you have access to a top-flight analytical facility, but those who come after you will too.
Thanks, John. So I'm going to go back to slides now. Whoops, I keep hitting the wrong button there. Sorry about that. Okay, so there we go. So one of the key answers to the question of why the lab is currently laid out the way it is a historical one. And there have been times during this, this pandemic process that we wished that we had given the mass spec side of the lab more space initially, because of course then we wouldn't have the same sorts of distance conflicts. But almost everything that is in the lab now is there because there was an instrument that came before it that occupied that space. And when we were doing the renovation in 2018, or 2017, 2018, 2019, the key was to keep the lab running while we upgraded it at the same time. And so it seemed like a good idea then. Okay, so here we go. Okay, so prior to pandemic and as we were outfitting the lab, we felt that it was very important to have as much remote access capability as we could have. And so we do that with a combination. We do a lot of Linux level stuff, and so I think one of the key tools for interacting with the Linux-based spectrometers is VNC. One of the key tools, I didn't write it down here, for interacting with the PC-based spectrometers, most of the mass spectrometers, is Microsoft Remote Desktop. And so those two tools give us the ability to sign on to an instrument that's currently running, to start and stop experiments as we need to, and to recover from hardware and software errors as they come up. So, you know, there are 4 of us as regular staff, and we work regular staff hours. And graduate students do not, postdocs do not. And so problems can come up anytime from midnight to 11:59. And most of those problems are really very easy to solve if you have the ability to dial up and fix what you need to fix. So, you know, we'll use VNC for keeping an eye on things. If we get an error report, if a piece of hardware isn't working the way it's supposed to, we can typically reset everything remotely now. And so that's a big deal for us. The very last piece of the puzzle that we figured out just a few weeks ago was a procedure for restarting the sample express. You notice we have 6 sample expresses in the lab without having to ask somebody to power cycle the device for more than months, you know, for a year, year and a half. What we've had to do is to make sure that there was somebody in the lab who could do things at the instrument. It's still a little dicey if there's a chance that a broken sample is going to be the result, but we haven't had any problems so far. So on the monitoring side, we will use VNC to keep an eye on automation queues. We have a website that does real-time status for the majority of our automation acquisition. And then we have a bunch of scripts. I like to write Perl scripts. Bruce likes to write Gawk scripts. We all like to write shell scripts to do a variety of things. And that variety of things makes it easier to create new users. It makes it easier to move data around from spectrometer to archive. We have a dedicated archive server that is basically a mirror of the data that's on an instrument at any given time, and is the primary connection point between the lab and the user with respect to data. So data from the automation systems, from the Brooker automation systems at least, goes via email, which means that those users typically don't use the archive server, but everybody else, whether they're manual NMR users or solid state NMR users or EPR users or IR users or mass spectrometry users, will go to the archive server in order to pull back what they need. Okay, so how did we manage the shutdown? As I said, that you know, I'm going to do that because that's easier for me. So on March 15th, everybody left. And the question was, what do we do in order to keep the lab running, or what do we do well, actually, do we keep the lab running? That was question number one. And if so, what do we do to keep it running? And if not, then what do we do to shut it down cleanly so we can start it back up? And so the first decision was an easy one. It was that we didn't want to quench the magnets because that was just too expensive, too much time, and too indeterminate with respect to startup again. So we immediately said, no, we're going to top up all of our magnets with helium. And I think we did that in the last 2 weeks of March. And we're just going to hope that there isn't some real trauma that takes down the helium service in the country. MIT is a little bit lucky because we have our own liquid helium distribution site because we do a lot of solid state physics. And so we've been tapping off of that for years. They go down, and when they go down, they'll go down for a month at a time for some very small reason. I think the last time they were down for a month or month and a half, it was because an old computer had failed and they were having trouble getting parts to replace it. So, you know, we have those issues, but for the most part, we're really pretty lucky because we can make a call on Tuesday and get helium on Thursday. And if it doesn't come till the following Tuesday, that's not really a big deal. We were told that nitrogen service would be okay. Nitrogen service, of course, can be a little bit more flexible. And so if we had to go without nitrogen for a week or a week and a half or 2 weeks, it wouldn't be the end of the world. So what we decided was that we were going to keep 2 staff on site and we were going to keep 2 staff at home, working from home. And we were in that process, we were going to always have 1 person off site for a week at a time. And the rationale was that if there was a transmission event, if for whatever reason, one of us got sick, or because there was a lot we didn't know about in March and in April. If one of us got sick and all 4 of us were in the lab, all 4 of us were going to have to quarantine. And we figured that that was the worst case. And so we tried to set things up so that there would always be somebody who was in a safe house somewhere who could come back and do what needed to be done. And so apart from the EPR, and I don't know if you took this point home from John's video, but the EPR is basically a cryoprobe system. There's a cryocooling unit that services the cold head, or the cold head services the probe, or the the active chamber for the EPR, which is kept at about 4.5 Kelvin. And so we knew that the labs that did EPR were not going to be doing COVID research. And so we shut that one down. And everything else, we just kept going. I don't know why that keeps happening. If you look just as an example of what our very complicated schedules were in March and April and May, and I think even through the first couple of weeks of June, we had these crazy routines where we had 2 of us on at any time. See, blue and green are on these 2 days, and then light blue and green is on that day, and then the 2 blues are on that day. But we always had 1 person who was out for the full week. And we did this so that we could overlap, so that everybody could overlap with everybody else, so that I could be in the lab when Mohan was in the lab, so that Bruce could be in the lab when John was in the lab, and so on. But eventually, when we went to our situation for June, when we went into phase 1, it became easiest and it made the most sense to just say 1 person out, 3 people on. And so that's what we did for phase one. Just to give you a sense of what the shutdown looked like, these are 7-day rolling averages for daily lab use hours, daily lab experiments. And I pull these from our billing records, basically. And so on March 15th, we go from steady state to nothing, okay? And the only change in this period was when we were helping with some of the COVID-19 work. This was a major peptide structure project where we didn't have a lot of samples, but we generated a lot of data. And you'll notice that on the recovery phase, we really got there pretty fast. So this inflection point was mid-June when we entered phase one. This inflection point is mid-July when we entered phase two. And I'll get to this in a minute, but phase one was when research restarted, and it restarted at 25% of capacity. Phase two was 50% of maximum capacity, and I'll tell you what that is in a minute. So you can see that even in phase one, even at the 25% level, we were basically up around 75% of normal use. And by now, I mean, this only goes out through the end of August, I think. By now, we're basically in the same place that we were back before the pandemic. This graph shows our training schedule, or at least our training requests. And you can see the same thing. They were pretty constant. Oh, I'm sorry, scratch that. This graph shows the number of users that we have in a given week. Whoops, I didn't do that. And so the number of users, of course, went from about 200 in a week down to nothing, and then started to come back up. So, and these are our average numbers. We had about 65 trainings per month prior to phase one. Now, to give you a sense in the more general view, and this data comes from Worldometers, which is where I look to see what's going on in the COVID world. MIT shut down research and sent all the students home here. And then they restarted research here. And I think we finally readmitted students right about here at, August 20 something. So the Institute was really very conservative about saying, if there's going to be this big ramp up in COVID activity, then we want everybody to go home. And then when we see that it really has gotten to kind of a leveling off phase, that's a good time to restart. And I remember that we were talking about starting phase one all the way back to maybe the third week of May. And we waited and we waited and we waited because we didn't want to see the curve spike back up and to have committed to bringing people back on campus. So we really did wait pretty well. So the rules for phase one were that labs could use 25% of what their maximum research hours would be within the limits, within social distance limits. So the equation was really a very simple one. And a lot of these parameters were decided based on the science that was available at the time. And that science has held true till today. So there's nothing inherently special about 6-foot distances, but if you keep people 6 feet apart, they're very unlikely to infect each other. If you keep people who are sharing space for a long time in 160 square feet per person, then they are very unlikely to infect each other. And so the phase 1 rules were designed to give us a chance to see how everything was going to go and to make sure that we allowed some level of research to take place. So if I'm a PI and I have 4 graduate students in my lab, basically the Institute said each of those 4 graduate students has 50 maximum hours at 100%. That was the standard that they set. And so each of those students can work 12.5 hours in a week, or 2 of those students can work 25 hours in a week, or 1 of those students can work 50 hours in a week, and then everybody else stays home. So that's what 25% meant. For us, we didn't operate on the 25% or 50% rule because we were a core lab, but we kept so at phase 0, we were at 50%. At phase 1, we were at 75%, right? We had 3 on and 1 off. So access to the building is limited to MIT staff, which means that anybody who is an external user couldn't get in. And so we had to accommodate that. The lab contamination control that we employed was twofold. It was a combination of airborne control, so everybody, and this is not a DCIF rule, this is an MIT rule, everybody on campus has to have a mask on inside. You have to maintain 6-foot distance, and there was a limit of 10 minutes in a core lab at a time, okay? And then the way we managed touch control was to wash and glove on the way in, and then remove gloves on the way out. So we were basically setting up a situation where if somebody came into the lab and was infectious, by washing and donning gloves, they didn't transmit that infection into the lab. If, on the other hand, there was infection inside the lab, by wearing gloves, right, because mistakes happen, by wearing gloves, you don't contaminate yourself. And by removing your gloves before you leave, you don't transmit that contamination outside the lab. So it's practically double barrier, where we make sure that what's outside stays out and what's inside stays in. Okay, so in phase 1, we gave up on manual use instrument reservations entirely, and a bunch of our instruments are manual use. So we just had to give that up, and we gave up user training. We flooded the user base with detailed guides explaining exactly what was going to happen. We answered a ton of questions, and that was just what we had to do in order to make sure that everybody was on the same page. Okay, this is, if you look at, this is our 501 magnet. This is the magnet that we use for combined liquid solids. And you can see that there isn't anywhere near enough space between those 2 magnet legs or anywhere around this magnet to teach somebody who's a new solid state user how to tune a probe. So we gave up on that possibility and said, if we need to do solid state samples, we'll run them ourselves. If we need to do external user samples, we'll run them ourselves. So that was kind of the key. So the phase 1 layout ended up looking like this, and these circles and arrows and there's a song about that that I won't get into, did not come from us. These came from MIT, and they said, what we want you to do is to mark up your lab showing what the distances are between sites where people might exist, and mark them as either static occupancy, these solid greens, or dynamic or transient occupancy. So if I was putting a sample on the 400, which has a Sample Express and is an automated NMR system, I had basically 10 minutes to walk in the lab. It was single entrance, single exit now, and we never had that before. Put my samples on a table over here, wash at the sink, put some gloves on next to the UPS, go over to the 400, put my samples in the automation queue, put my samples in the sample changer, and then exit by one of the exit doors, either this one or this one, okay? And that ended up working out just fine. Now, one of the rules that I talked about, this 160 square foot rule, meant that as an NMR lab, I mean, NMR lab's pretty big. We could actually have double the number of green circles that we have here. 1, 2, 3, 4, we have 8, and we could have had 16, but we didn't really need it. On the mass spec side, it was a real limitation because we've got 1, 2, 3, 4, 5 instruments plus the HPLC, and we only had enough space to accommodate 2 people at a time. And so that was one of the motivators for turning off the reservation system and doing reservations manually, having people send us email to say, this is when I'd like to use an instrument, can you accommodate me? And then we would book people in. So if we booked somebody in for the MALDI, we couldn't book somebody in for the QTOF, which is where this green circle is. If somebody was coming in to put samples on one of the auto sampler mass spectrometers, the LCMS or the GCMS, that was fine. We didn't need to schedule that. So in phase 2, we doubled the amount of time that research users were allowed to do research. We also shrunk the long-term square footage based on, I think, probably newly developed science to 125 square foot per person, which would have made it easier, I think, for some of the smaller labs. It meant for us that we could actually do 3 people in the mass spec space at a time, except for the minimum distance rules. Okay, so the way that we made that change, and I didn't point this out, but in phase 1, we were only open 8 to 6. And we were only open 8 to 6, Monday through Friday at the start of phase 1. We very quickly had to react to the fact that a lot of the labs, in order to spread people out, went to 7-day rotations. So, it only took about 3 days before somebody called me up and said, my only lab time is Saturday afternoon, and what do I do about submitting NMR samples? And so very, very rapidly into phase 1, what we did was to rejigger and say, okay, so we're going to keep the lab open 8 to 6, 7 days a week, but only for automation. And that solved the problem right there. So during phase 2, and this is where we are now, the lab's open 24 hours a day, 7 days a week. We turned on our reservation system, and I honestly don't know whether we get 10 reservations a day or 50 reservations a day. It really is more than the lab staff can handle on an ongoing basis, certainly at 50%. But the reservation system that we have, which was developed and fully authenticated by Jeff Simpson many, many years ago, has served us extremely well in this capacity. We did use that reservation system, I'll show you in a minute, to make it possible to enforce the social distance rules and still allow it to operate in an automated way. We had a process that we called walk-on time that we replaced. We put high resolution mass spec on a rotating basis, and we restarted trainings. But those trainings are a combination of video instruction, and that video that you saw from John is one example of that, and Zoom sessions. So we'll actually set up Zoom sessions to go through a significant fraction of what we would normally do in front of a spectrometer. And again, if you have remote access into a spectrometer, you can VNC into one, then you can share your screen from your office or from your home, do a training with users who are in their homes, and get a good fraction of the training that you need to do. You can show the software very well, and if you have good video guides, you can show the hardware reasonably well. And again, we detailed all of this via guides that we sent in emails. So this is what the phase 2 plan looked like. Really, it's not any different in the mass spec space, and we were able to add a few more simultaneous circles in the NMR space, but otherwise it wasn't much different. This is the way that we accommodated. So if you look at these pictures, you see that going from bottom to top, here's the QTOF. It is easily within 8 feet of the MALDI, and the MALDI is easily within 8 feet of the AccuTOF. So, you know, these are basically adjacent bays, and these, the QTOF and the MALDI, are in the same bay. And so you really don't have the flexibility to say, if somebody wants to run the AccuTOF, then somebody else can run the MALDI at the same time. And so the paradigm that we employed was one of these rotating scheduling paradigms. And in our reservation software, the way we managed this was to simply block out the reservation possibilities for those instruments that couldn't be reserved. So if the MALDI can be reserved from 2 to 10 on Sunday night or Sunday morning, then the AccuTOF and the QTOF cannot. There's some flexibility there, because we can also employ a certain amount of remote access for those instruments when it's really important to do so. And we've had cases of that where people have schedules in the lab that don't work with this rotating sign-on schedule. I wanted to, you've seen a lot of this signage already in the video, but this is one of the key parts. It's, you really need to focus on communicating what people have to do in order to stay safe. You enter here, you exit here. You throw away gloves if you've come down to the lab with them on. You put gloves on after you come into the lab. You wash before you put your gloves on. The gloves are here. I mean, we go through an awful lot of gloves, but this is the cost of doing business in this environment at this time. These posters on the right are actually the ones that the Institute has plastered all over campus. You know, basically every door. I think you'll probably see one of these in every bathroom. It's really pretty impressive. So, so I'm going to sum up by giving my perspectives, which are that where we started was with a set of guidelines that MIT set down based on the governing science and said, this is what you have to do in order to keep people safe in the research environment. Our approach to that was to keep as much lab function as we could during phase 0, phase 1, phase 2, while operating within those guidelines. And then we were as cognizant as we could be of communicating effectively to our users, and to developing as much remote access, virtual tools and stuff to do the job. So this just happened to be one random day when I brought my camera into the lab, and in the space of about an hour, I captured these images of people at the LCMS, 2 of the NMR systems, and the EPR. And with that, I believe I am done. So I am going to stop sharing my screen. I'm going to turn it back over to Mark to triage any questions. If you do want to submit questions, use the Q&A feature, and he will pick them up from there.
Thanks very much, Walt. It was a great talk. Going forward, you know, I'm assuming universities are like Petri dishes at the best of times. Will you be retaining any of these once the COVID crisis is over? Any of these, like, you know, wearing gloves in the lab, or?
I don't think so. So my guess is, because really we've never done that, right? We've never had it as policy that people should have gloves on in the lab, partly because, and you know, it was a change in mindset. If I'm a chemist, I wear gloves when I'm at the bench. And then when I leave the bench, I take my gloves off, because I don't want to give the impression that whatever was on the bench, whatever was in the flask, I'm carrying around to the rest of the building. Mm-hmm. And of course, having gloves, having this process of using gloves is expensive. We go through somewhere on the order of 4 boxes of gloves a day.
Yeah, it's a lot of waste as well.
It's a tremendous amount of waste.
Mm-hmm.
It's an expensive endeavor. I mean, we have to do it now.
Yeah.
We have a little box of masks that we sit at the same table that we have gloves. I'm not really sure why, because people are required to have masks on before they enter the lab, but I think just in case a mask breaks when they're in the lab, they can grab another one. But no, I'm sure that we will we'll go back to what our standard process was as soon as we can. So people won't be wearing masks once there's no need, and people won't be wearing gloves once there's no need. But these procedures won't go away. So if this happens again, then we know exactly what to do. So, and it's possible that if this happens again, we, you know, if there's another pandemic, that we have the ability to institute some of these processes without having to do a complete shutdown next time. because that shutdown was expensive too. It was 3 months of no research.
So, so you're all set for COVID-19S, COVID-20. Is there any track and tracing done? Like, so if somebody who used the open access lab a few days later tests positive, would you ever find out about that, or?
Yes, yes. So at the institute level, we're pretty well designed to handle contact tracing. One part of this that happens at the higher level, at the institute level, is that anybody who's on campus gets tests. Anybody who's on campus regularly, 5 days a week, has a COVID test twice a week. Okay, so we're doing everything that we can to identify anybody who's actually infectious. Anybody who is infectious automatically goes into the quarantine stage, so they get removed from campus, and then the contact tracing team will work with them to understand where they've been, who they've seen, and who should be contacted. And this is not so straightforward. There's this tricky balance between confidentiality and public health that we really have to pay attention to. And so I think the rule is that if somebody has been in the DCIF, I'll make it personal, somebody who tested positive yesterday who tested positive tomorrow was in the DCIF yesterday and spent less than 20 minutes there and didn't get close enough to anybody to potentially transmit, right? So kept 6 foot distance, then we'll never know about it.
Oh, okay.
Okay. If for some reason they say, yeah, I was in the DCIF and I was within a few feet of somebody because I was putting a sample on the LCMS and they were putting a sample on the GCMS, and they dropped their pencil and bent down to pick it up and I coughed in their face, and that person would get notified that they're at risk and they would quarantine as well. And if one of us was setting something up on the GCMS and the same thing happened, we would get notified and we would go into quarantine.
We have a question from Victor Beaumont.
Yeah.
In your opinion and experience, how well have the students been able to adjust to work within these restrictions?
The students have been outstanding in their ability to work within these restrictions. In the entire time from June 15th till now, there was only one case that I know of where a student came into the lab without a mask. It was on a Saturday, it was from a distal site, and it was very early on in the process. And so I'm guessing that that student simply forgot. Actually, it was a postdoc, wasn't a student. I'm guessing that that postdoc just wasn't used to the right thing to do. With respect to gloves and washing, people will forget from time to time. They forget much less often now than they did in June. But it has never been a problem to look at somebody and say, and you know, you'll get a kick out of it because somebody has sat down in front of one of the automation systems, and you'll hear them say, "Oh no," and then they'll jump up and they'll go wash and they'll put gloves on and then they'll go back, right? And it's just that they forgot.
Yeah.
But because everybody is doing it, there's really very little risk that even if they were infectious, that the next person to sit at that instrument is going to run the risk of getting disease. So, and of course, if we see something like that, well, we'll wipe down the keyboard and mouse,
Yeah.
because that's really all you have to do. And we have spray bottles everywhere. so it's easy to do. We decided not to do that as a routine matter because we figured it was mostly going to just cause us to need to replace keyboards and mice all the time.
Another comment from Donna Baldesseri. Says very detailed report on safety measures. It would seem like this would help a lot of managers. Any chance of this being posted to AMMRL? I mean, the recorded video. So just something to consider, I guess.
All right. Yeah, I think we're still recording, so I can certainly figure out a way to post it. So I'll follow up with AMMRL.
Okay. Is there any other questions? You have a couple of seconds to type something out. Otherwise, we'll wrap it up for today and thank Walt for a really good talk. And how labs could handle this very unique situation, which we hopefully won't have to go through ever again. So don't put that energy out there. But thanks once again for a great presentation, and I hope to see everybody next month in October 14th, I believe, for a talk by Ron Crouch from JL USA. Thanks very much, Walter.